with the northern lights, if we've got a chunk of stuff coming from the sun, eventually that stuff, and all of it is charged particles, right? So the sun is made of plasma. Plasma is just particles that have been just hopelessly ionized, right? That chunk of stuff, as it flies toward the Earth, these charged particles, and typically we have these when you've got a ton of sunspots, okay? When there's a ton of sunspots, the sun tends to those magnetic field lines bend and snap, and it tends to shoot chunks of stuff. They fly toward the Earth at great velocity. When they encounter the magnetic field lines, remember that they just spiral around them, okay? They will follow those field lines. So if the field lines bend and it happens to hit this thing with a component of velocity that heads it toward the North Pole, then it's going to spiral its way in and hit the North Pole. Then it becomes the aurora borealis. And if it happens to come down here and hit more like this way, right, and it spirals toward the South Pole, and when it strikes the atmosphere of the Earth at the South Pole, it becomes the aurora borealis. Now, borealis is north. It's then the australis, or aurora australopithecus. I don't know. Okay, that means southern, right? Yes, Australia is the southern continent or something like that, right? So either way, you get lights on either side. Now, what? It's the southern northern lights. Yes, there we have it, right? Okay, so when it strikes the Earth's atmosphere, it makes all these really cool things. Basically, if you've seen, and I have seen this, okay, if you've seen water striking, if you've ever been underwater and seen a waterfall, have you ever done that? Swum underwater to see the waterfall? Okay, they're cool. Like the water impinges on this stationary thing of water. That's what northern lights are like, is like this material is actually striking the Earth's atmosphere. These are the spectral lines. We're exciting those atoms, and that's where you get the colors from. Like, I think this is nitrogen. I can't remember what red is. Okay, this is a time-lapse photograph, so the northern lights have sort of smeared a little bit. They actually have sort of a fine structure like this. This is a shorter shutter speed. And you can see that the sheets, they look like curtains like that. It looks a lot like a waterfall striking the surface of a lake. This is even more pronounced, right? These little things. This is like a little shaft of stuff from the sun that's penetrating the Earth's atmosphere like that, right? Why are they what? Because you're closer to the Earth's magnetic North Pole, right? The farther north you get, the more you see them. I've never seen them in Oregon ever, okay? And I think it's partly because of I didn't look at the right time. Has to be like a solar sunspot maximum is when they tend to be. But back in the 80s, I know that we had northern lights that were so bright that I could read by them. And I know this because I took a book outside on a moonless night, and I read by the northern lights. They were that bright. Yes? No. This is in Wisconsin. Okay? There's no reason, though, that I think you shouldn't be able to see it, except that I think maybe the Earth's magnetic North Pole is actually more east. Right? It's in northeastern Canada, so we actually are, although we're as close to the axial pole as Minnesota is, right? We are pretty far east, I think, to see them, so we need to get a little farther north to get the... And then this is, I just like the red color. I thought that was cool. Here is, and this is kind of fun, this is a bubble chamber. Now, take a look at this set of tracks here. Do you see this thing here? This is, and this is especially a good picture of it. Do you see that? Something, first off, there is nothing here, and a particle sprang into existence. So what happened here was, this is called pair production. Probably some very energetic particle, like a very energetic photon, okay, came in there and spontaneously created matter. And when it did that, it had to create a matter particle and an antimatter particle. We'll talk about this later, okay? And so it created, in this case, I'm guessing that this is a positron and an electron. A positron is an antimatter electron, okay? The positron spiraled one way, and the electron spiraled the other way because they have opposite charges. Antiparticles have opposite charges. And so that's kind of cool. All I wanted to show you, though, is that it spirals. Here's another pair production event. What? This is a picture from a bubble chamber. Yeah, it's a real picture, right? So bubble chamber is, I think they have like liquid hydrogen or something like that, and they have it above its boiling point, so the particles actually cause it to boil. It's like putting like salt in beer. Makes it foam up like crazy, right? Really? Yeah, it really does. You'll find that out in 4 years.